Introduction to Video Systems Theory about video signals, audio signals, analog television systems and radio. Audio and video signals have a wide range of applications, and it would be useful to review the purposes of each of these signals. The word video comes from the Latin meaning I see, while the word audio refers to I hear. These two terms reflect their distinctive roles, with video used to record light and visuals, while audio is used to record sound. The differences between the two are explained in detail in Figure 1.1. In Figure 1.1a, a commonly used audio system involves the use of a microphone to convert sound waves into electrical signals suitable for audio signals. Loudspeakers, also known as loudspeakers, receive these audio signals through input terminals, either through a direct connection or as part of a wireless broadcasting system. Next, the loudspeaker reproduces the original sound originally recorded by the microphone, so that we can hear it clearly as recorded by the microphone. In Figure 1.1b, it can be seen that the camera tube has an important role in converting incoming light into appropriate electrical changes to produce a visible video signal. In video systems, this camera tube is equivalent in function to a microphone in an audio system. In the final stage of the video system, the picture tube converts the video signal voltage from the input to light at the output. The resulting visual information is then displayed back on the image tube screen, so that we can see the image according to what was recorded by the camera tube. Figure 1.1. Comparison of audio and video signals used in electronics. A. Audio signals for sound. B. Video signals for images. Difference between video and audio. The light image in the video context is converted into an electrical signal only for a small area at a certain moment. As a result, the video signal produced by the camera tube includes sequential changes in time for different areas. Therefore, a scanning procedure is needed to cover the entire image, namely point by point from left to right and line by line from top to bottom. This scanning process is very fast, requiring only 63.5 microseconds, microsec, for one horizontal line. Due to this fast scanning, the video signal has a high frequency, reaching around 4 MHz. During the scanning process, synchronizing pulses are used in conjunction with the video signal to time the scan on the camera and picture tube. On the picture tube, small light areas or shadow areas, if any, are reconstructed in the correct positions to accurately form the overall image. Basic frequency signals in video and audio. Video and audio signals have a characteristic called the basic frequency region, baseband, which reflects changes in frequency without any additions such as encoding or modulation for certain functions. Basically, these frequencies correspond to the desired visual or sound information, without any complex changes. In the context of audio systems, the fundamental frequency width, baseband, ranges from 20 to 20,000 Hz, but often the 50 to 15,000 Hz range is used for high-quality audio. On the other hand, in video systems, the basic frequency range starts from 0 Hz for direct current and reaches 4 MHz. An audio fundamental frequency signal can be transmitted to a loudspeaker to produce the desired sound, while a video fundamental frequency signal can be sent to a picture tube to produce the desired image. The reason behind converting sound and image information into fundamental frequency electrical signals is the ability to amplify audio and video signals as needed. In addition, signal processing through electronic circuits is relatively easy and can be applied in various contexts of use. Radio transmitting signal. In wireless radio transmission, a base frequency, baseband, audio signal is used to modulate a radio frequency, RF, carrier wave. This modulation is necessary because the audio frequency is too low for efficient transmission. In addition, different radio stations use different carrier frequencies. The radio receiver can be tuned to the desired carrier frequency. In the radio receiver, the modulated RF signal is detected to restore the original audio information. Television transmitter signal. The same concepts apply in television transmitters as are used in radio transmitters. The video fundamental frequency signal is used to modulate the high-frequency carrier wave to complete the wireless transmission. In television receivers, video detectors are used to recover the original video signal. The process for television broadcasting is similar to radio broadcasting, except that video modulation is used for the picture signal, and the sound signal is included on a separate carrier wave. All of these systems require electromagnetic radio waves for transmission. In television broadcasting, amplitude modulation, AM, amplitude modulation, is used for picture signals, while frequency modulation, FM, frequency modulation, is used for corresponding sound signals. Television broadcasting. The term broadcast means sending information in all directions. As shown in Figure 1 to 2, the transmitting antenna sends out electromagnetic radio waves that can be received by the receiving antenna. Television transmitters have two main functions, namely sending visual information that can be seen and audio information that can be heard. An amplitude-modulated, AM, picture signal and a frequency-modulated, FM, sound signal are sent together from the transmitting antenna. The service area covers approximately 75 miles, 121 kilometers, in all directions from the transmitter. In the process of visual transmission, the camera tube plays an important role in converting light images into video signals. This camera tube is a type of cathode ray tube, CRT, consisting of a photoelectric image plate and an electron gun enclosed in a vacuum-filled tube covered with glass. One type of camera tube commonly used is the Vidicon, which can be seen in Figure 1 to 3. Basically, the camera tube captures an optical image of the scene or scene on its photoelectric plate. The plate is then scanned in horizontal stripes by groups of electrons moving from left to right and top to bottom, when viewed from the camera's perspective. Figure 1.2 block diagram of television broadcasting system. This scanning process takes approximately 1/30th second to cover the entire image, consisting of 525 scanning lines. As a result, the output from the camera tube is a sequence of electrical changes, known as a video signal, that corresponds to the image information. This video signal is then amplified, and alignment pulses are added. Amplitude modulation of the image carrier frequency produces an image signal in the form of amplitude modulation, AM. Figure 1 to 3. Vidicon camera tube. Length 6 inches, 152.4 millimeters, RCA. The receiving antenna functions to capture image and sound carrier signals. These signals are then amplified and then detected to obtain the initial modulation. The output of the video detector includes the video signal required to reconstruct the image. Next, the detected video signal is amplified to the extent necessary to drive the cathode grid on the picture tube, as depicted in Figure 1 to 4. This picture tube is similar to the cathode ray tube, CRT, used in oscilloscopes. This tube screen has a tuning plate made of glass on the front with a phosphor coating on the inner surface. At the neck of the tube there is an electron gun. When the electron beam hits the phosphor screen, light is emitted. For example, if the video signal voltage makes the control grid less negative, Then the electron beam current will increase, making the emitted light brighter. The maximum light emitted is bright white light on the screen. Conversely, a more negative voltage will reduce the beam current and make the screen darker. If the grid voltage is negative enough to cut off the beam current, then no light will be emitted. This corresponds to the black color on the screen. The block diagram in Figure 1 to 2 illustrates the system for monochrome images. In color television, a color camera and a color picture tube are used. Color cameras produce video signals for image information in 3 colors: red, green, and blue. Similarly, the color picture tube allows for reconstructed shading in red, green, and blue, as well as all mixtures of colors in between, including white. Figure 1.4 Television Picture Tube, CRT, Cathode Ray Tube. Television broadcasting channels. The width of the frequency spectrum used to send video and audio signals is called a television channel. Each television station is assigned by the FCC, Federal Communication Commission, to a channel with a width of 6 MHz and a certain carrier frequency. As shown in Table 1:1, all television channels are divided into 3 spectrum width categories. Television channels are special allocations within the frequency spectrum that allow the broadcasting of television content. This division is important to prevent interference and ensure that each television station has a unique channel for their transmission. It also makes it easier for viewers to tune their television receivers to specific channels to watch the programs they want. Television broadcasting channels. Television channels are divided into 3 categories based on the width of the frequency spectrum. 1. Low-band VHF, very high-frequency channels. This includes channels 2 to 6. 2. High-bandwidth VHF channels. This includes channels 7 to 13. 3. Ultra-high frequency, UHF, channels. This includes channels 14 to 83. Note that this frequency range is 30 to 300 MHz for VHF and 300 to 3000 MHz for UHF. Each television channel has a spectrum width of 6 MHz. This spectrum width is required to accommodate video frequency modulation up to 4 MHz, including the 3.58 MHz color signal for color television. In addition, the FM sound signal is also present in this channel. The audio and picture carrier radio frequencies, RF, are always separated by 4.5 MHz on all channels. This 4.5 MHz frequency is referred to as the intercarrier sound frequency. When television was first introduced in the United States, Channel 1 used the 44 to 59 MHz frequency range, but now this frequency band is used for other services. Between channels 4 and 5, the frequency 72 to 76 MHz is used for other radio services, including air navigation. An FM commercial broadcast channel with a wide spectrum of 88 to 108 MHz is directly above the frequency area of television channel 6, but is not related to television broadcasting. In 1952, UHF channels 14 to 83 were added to increase the number of television stations. No television stations are allowed to work on UHF channels 69 to 83 as these frequencies are used for mobile radios. In the receiver, a radio frequency tuner (RF tuner) is used to select the desired station by tuning to 6 MHz spectrum width. With 2 rotatable tuners, one for VHF and one for UHF. The receiver can tune in to VHF and UHF channels. The channel position on a single VHF tuner is used to turn on the tuner. In the wide spectrum of VHF and UHF, signals are propagated by line-of-sight transmission from the transmitting antenna to the receiving antenna. Usually, these signals do not follow the curvature of the Earth and are not reflected by the ionosphere like radio signals at low frequencies. This line-of-sight transmission makes antenna height critical to getting good coverage of television broadcast signals. The FCC is responsible for establishing television channels and maintaining strict technical standards. Each station must meet FCC requirements and serve the needs of the community. The station's license is periodically reviewed, and the public is invited to participate in this renewal process. How television studios work. In the early days of television, most programs were broadcast live, and each television station used studio cameras to produce their own programs. Network federations provide programs to cover areas across the United States. Major networks include CBS, Columbia Broadcasting Company, ABC, American Broadcasting Company, and NBC, National Broadcasting Company, which is owned by RCA. The distribution of network programs is managed by the Bell Telephone facility. Microwaves and cables are used to connect areas with a wide spectrum of frequencies. An additional source of television programming is using 35 mm film. Television film cameras convert the optical image from a camera tube into video signals. In the past, most television programs were produced and stored in tape format as a memory system. Magnetic video tape recorders, VTR, do for video programs what audio tapes and phonograph records do for audio programs. The main advantage is that these programs can be recorded on tape at one time and stored for broadcast at a later date. Advertisements can also be stored on the videotape. Another advantage is that programs delivered via microwave or satellite can be recorded during off-peak hours and then broadcast at the time most convenient for the station. Studio Transmitter Link, STL, Studio Transmitter Link. Typically, studios where video and audio signals are produced, and where tape machines are installed, are located in central areas of the city for easy access by programmers. Or these programs can come from outside the studio. However, the transmitter is in a remote location, usually the tallest building. Basic frequency video and audio signals are delivered to the transmitter via microwaves or via a wide-range cable system provided by Bell Telephone. In many cases, the transmitter has its own separate microwave connection, called an STL. The transmitter uses a microwave antenna, which is installed in the studio and the transmitter. The microwave dish seen on top of the tower in Figure 1 to 5 was used for this purpose. STL systems operate in the frequency range between 2 and 12 GHz, GHz, which the FCC has designated for all 3 American stations. Figure 1.5 Television Transmitter Antenna Electronic News Collection, Electronic News Gathering, ENG, as video recording technology, commonly known as video cassette recorder, VCR. Improved to meet minimum broadcasting requirements, electronic news gathering, ENG, systems evolved. ENG involves the use of a portable television camera and VCR. This camera is designed to be very compact, making it easy to carry. The camera and VCR were powered by a battery pack attached to a belt worn by the camera operator. ENG replaced the use of portable film cameras. Signals from ENG equipment can be easily accessed. For later playback, recorded tapes can be sent to the studio. Or the basic video and audio signals can be sent over the microwave connection to display on the screen. Electronic field production, EFP, electronic field production, EFP, systems also use compact portable video equipment, similar to that used in ENG. However, the goal of EFP is to produce entertainment events in locations far from the studio, such as a documentary program or an interview in someone's home. Switching and mixing. All cameras and video recording equipment are connected via a synchronization generator, so playback is uniform for all sources. This method enables electronic switching between various devices such as video recording programs, live sources, and special cassette recording equipment used to store commercial shows. In this process, minimal disturbance occurs. You see a black screen while switching is performed in a blank vertical interval. At that time, the screen is in the off state, while the electronic playback track moves from the bottom to the top of the image frame. This vertical discharge time is relatively long, around 1300 microseconds. Thank you for watching.